Okay, hello Math 115 students. I've created several YouTube videos to go along with these notes here. So we'll get right to it. We're doing chapters 1 through 5, and I'll just go in the order that you see here. So section 1.1 is called functions. The definition of a function. So it says let x and y be two non-empty sets. So I got two groups. Each group has at least one item in it. Then a function from the first set into the second set is a rule that associates with each element of the first set to exactly one element of the second set. So exactly one, that's key words there in the definition. Okay. So as an example, what if the first set is age, or what I'm calling x, and the second set, y, is height? So is that a function? Well, does each person have only one height at a particular age? That's the question. And the answer is yes, right? Nobody can have two different heights at one point in time. So since, like, on my 18th birthday, let's say, I had exactly one height of 69 inches, that would be a function. Okay, if I switch x and y though, if x is height and y is age, that's not going to be a function. So somebody who is 5 feet 11 inches, let's say, doesn't only have one age, right? There's lots of people that are 5 feet 11 inches that have several different ages. You could be talking about an 18-year-old, or you can be talking about a 72-year-old, right? And so it's that's not going to be a function. Okay. Now here's another example. So what if I were talking about the statement was born on? Okay, I've got a set of points, and I've just made up some names and some dates where these people are born on, we'll say. Okay, here's a picture representing what's going on. So I got a group of people, here's the 4 names, and then I got the corresponding birthdays listed. So Matt's birthday is on April 15th, Andy's birthday is on May 3rd, Michelle's birthday is on March 26th. And just to make this a little bit more interesting, suppose that Nate and Andy have the same birthday, which is May 3rd. Okay, is that a function? Well, yes, it would be. Okay, since each person has only one birthday. Nobody can have 2 different birthdays. That's impossible, right? So everyone has exactly one birthday. Now, maybe if you're unsure, you're probably unsure because Andy and Nate have the same birthday. Is that okay? Yeah, there's lots of people in the world that have the same birthday, right? But everyone has one birthday. Each person has one birthday. Okay. Here'd be another example. So what if I had this set of points? I'm using set notation there. We're going to do lots of things with set notation coming up. I got things in x and things in y. The things in x would be the numbers in the x coordinate positions there. So I got 9, -3, 9 again. I don't have to write that again. Then -2 is y, the y value. 5 is a y value. 2 is the y value. Okay, and then I'm drawing my connection arrows, or my correspondence arrows. So 9 is going to -2, -3 is going to 5, and then 9 is also going to +2. Is that a function? Okay, and the answer to that would be no. Since each x value doesn't have exactly one y value. Okay, 9 is going to 2 different places. 9 is going to -2 and 9 is going to +2. You can't have that. Okay, so this would not be a function. One way that I like to kind of explain this is that, if by the way, if you're a visual learner, I encourage you to draw like pictures like what I've got there. Okay, and each x corresponds to only one y. Now it can be the same y, like in this example up here. Andy and Nate had the same birthday. That's okay. Okay, you just can't have an x value going to two different y values. So one way to describe it is like you got a person on the left side of this picture, and they're going to walk over to the right side. The person who's walking over the right side cannot be in two places at one time, right? That's impossible. So any situation that would look like the one that we've got here is not going to be a function, okay? And the next thing, function notation. So usually the letters F for function, G, H, K, there's others, are going to represent functions. Okay, f of x is most common. And so the way that I would read that is to say f of x, and I'm talking about the value of f at the number x. So now one of the things that we're going to care about, we'll talk about this more in the next section, 1.2, is the domain and the range of a function. The domain of a function is the set, that's a key word there, the set of all possible input values. So what's going into the function. Whereas the range is the set of all possible output values. So what's going out of the function. Those are two different things, right? So like, if I just go back to this problem here, these names, those would be the input values, and the dates that they're born on would be the output values. Okay. Here's another example. So what if I had this information? F of -1 equals 5, f of 0 equals -3, f of 1 equals -1, and f of 2 equals 5. F is a function, okay? So I'm supposed to write f as a set of ordered pairs and then give the domain and the range. Okay, so well, the numbers that are on the left side of each equation, those will be the x values, and the numbers that are on the right side are going to be the y values. So the first point would be -1, 5. The next point would be 0 or -3. And then 1, -1. And then 2, 5. Okay. Now, by the way, is this a function? Like I'm using function notation here. Is this actually a function? Well, the answer would be yes. I have two different x values, -1 and 2. They're going to the same y value. That's okay, right? Like we just talked about this example. I got two different x values going to the same y value. You cannot have an x value going to two different y values. Those are not functions. Okay, so I do have a function. I'm calling it f of x. And I want us to state the domain of f and the range of f. So the domain is defined to be a set, same as the range. And I'm using set bracket notation there. By the way, another common notation that you'll see all over the place in this book is interval notation. We'll talk about set notation and interval notation shortly here, actually in another video. But the domain would be the set of all input values, or all the x values. Okay, so that's going to be the set containing -1, 0, 1, and 2. And then the range would be the set of all y values. So that would be 5, -3, -1, 5 again. Now, do I have to write 5 again? I could. I could actually write 5 as many times as I want to. You know, like I could write 5 23 times if I wanted to. Why I would do that, I don't know, but I could. Okay, I would still just count that number that's 1 that is different from the others. Okay, so there's no reason to write, 5 again, although I could. Okay. By the way, we're using set notation here. Now, we don't care about the order of the elements. So, I could say the set containing -1, 5, and -3. That'd be fine. Just make sure that I've got them all listed. Okay, like we're not concerned about the order of these elements. The vertical line test is probably something you've heard of before. So it says that if every vertical line intersects a graph in at most one point, then the graph is a function. All right, so here's one example. I got a curve. And if I draw a vertical line anywhere, it's not going to matter where, the vertical line that I would draw is only going to intersect that curve in one point. So that would be a function. Okay, so if I wanted to, I could call this f of x or g of x or whatever. Okay, how about this example? So this is a parabola. We're going to do lots of things with parabolas. Okay, now this parabola is kicked on its side and facing towards the right. Is that a function? Well, no, it's not going to be a function, because if I apply the vertical line test, this line is going to intersect the curve in more than one point. It intersects in 2 points. It says not a function. You can't have that. Okay, now if I were to draw a vertical line over here, let's say, I'm not intersecting the graph, right? Because I don't have any graph over here on the left side of the y-axis. Okay, but that's not what the test says. It says if every vertical line intersects a graph in at most one point, then the graph is a function. So yeah, you're all good on the left side of the y-axis, but where the test fails is where you get over to the right side. Okay, all you need is one vertical line to intersect the graph in more than one point for the whole thing not to be a function. Okay. Now we're going to do lots of things with the vertical line test and functions. So that's very important stuff. So whenever you're drawing a function, you want to make sure it passes the vertical line test. Okay? If you swing a vertical line across the graph, that way, you want to make sure that it's only going to intersect the curve in one point everywhere. Okay? And then we have what's called the horizontal line test. Now the horizontal line test is a test more kind of explained in another section here when we talk about inverse functions. But it says if every horizontal line intersects the graph of a function and at most one point, then the graph is called one-to-one. Okay, so let's see. Here's a parabola. If I apply the horizontal line test, that's not going to work, right? Like, so if I draw a horizontal line anywhere above the x-axis, I'm going to intersect the curve in 2 points. Okay, so this would not be an example of a one-to-one function. Okay, but if I had this other function, suppose g of x is x cubed, that'd be this graph. And by the way, in this section, we'll look at some basic functions in the next video. I'll show you that. But these are functions that are going to come up over and over and over again. They're just worth knowing. Now, if I apply the horizontal line test to this guy, if I draw a horizontal line anywhere, a horizontal line that I would draw is going to intersect the curve in only one point. So yes, that's going to be a one-to-one function. Okay, now the graph has to be a function when applying the horizontal line test. You have to have a function. So I have to have something that will pass the vertical line test if I'm going to be then talking about a one-to-one function. Okay, because if it doesn't pass the vertical line test, it's not a function, right? Okay, so we'll go ahead and stop the video right here, and I'll pick up with this example in the next video, and we'll probably look to finish up section 2 or 1.1 here in the next video. Okay.